Welcome to this deep dive into Kubernetes Gateway API. Today we'll explore the modern, extensible approach to traffic management in Kubernetes clusters, going beyond basic ingress to understand advanced routing, security, and multi-cluster capabilities. The Gateway API is a collection of resources that provide a way to expose Kubernetes applications to external traffic. It's designed to be the evolution of the Ingress API, offering more powerful and flexible capabilities for traffic management. Let's explore the core components of the Gateway API architecture, starting with the gateway resource itself. Here we see the core Gateway API components within a Kubernetes cluster. At the top is the Gateway class, which defines a set of gateways with common configuration and behavior. The gateway itself implements that configuration in a specific namespace. Then we have various route resources like HTTP route that define specific routing rules for different types of traffic. The gateway class is a cluster-scoped resource that defines the configuration template. Controllers implement gateway classes to provide specific functionality like load balancers or service mesh gateways. The gateway is a namespaced resource that represents a load balancer running at the edge of the cluster. It implements the configuration specified in the gateway class and provides an actual load balancer or proxy for routing traffic. The HTTP route is a routing resource that specifies how HTTP traffic should be forwarded from the gateway to Kubernetes services. It contains matching rules, header manipulations, and traffic splitting capabilities. Besides HTTP route, Gateway API supports other route types like TCP route, TLS route, and UDP route. This multi-protocol support is one of the key advantages over traditional ingress, which only supports HTTP and HTTPS traffic. At the bottom we have our applications, App A and App B, which receive traffic routed through the gateway and its associated routes. The gateway acts as the traffic entry point, directing requests to the appropriate services based on the routing rules defined in the various route resources. External traffic flows from the internet to the gateway, which then routes it to the appropriate applications based on the rules defined in the HTTP route and other route resources. The gateway class provides the template for configuring the gateway itself. This architecture provides a clear separation of concerns between gateway class, gateway, and route resources, making it easier to manage complex traffic routing requirements in Kubernetes environments. Now let's dive deeper into each component, starting with gateway class. A gateway class defines a set of gateways with a common configuration and behavior. It's a cluster-scoped resource that acts as a template for gateway resources. Think of it as a blueprint that defines what type of gateway to create and how it should behave. Next is the gateway resource, which is a namespaced resource that represents a load balancer operating at the network edge. It receives traffic from outside the cluster and forwards it to Kubernetes services. The gateway is a managed resource that implements the configuration specified in the gateway class. HTTP route is a key routing resource that specifies how HTTP traffic should be forwarded from a gateway to Kubernetes services. It defines matching rules, header manipulations, and traffic splitting capabilities. HTTP routes can be attached to gateways to define specific routing behavior for HTTP traffic. Now let's explore the advanced routing capabilities of Gateway API. This includes traffic splitting, path-based routing, header-based routing, and more sophisticated load balancing strategies that go beyond what Ingress can provide. One of the advanced capabilities is traffic splitting, which allows you to distribute traffic between different service versions. This is particularly useful for canary deployments and A/B testing scenarios. Another advanced capability is path-based routing, where different paths in the request URL are routed to different services. This allows you to serve multiple applications through a single IP address. These advanced routing capabilities make Gateway API a powerful tool for managing complex traffic patterns in modern Kubernetes environments. Let's compare Gateway API with the older Ingress for a better understanding of the improvements and differences. This comparison shows the key advantages of Gateway API over Ingress. Gateway API supports multiple protocols and traffic types, offers high extensibility, has better multi-vendor support, provides native multi-cluster support, and includes advanced security policy options, while Ingress has lower complexity and is more mature. Gateway API is the future of Kubernetes traffic management. Finally, let's look at how Gateway API enables multi-cluster scenarios, which is challenging to implement with traditional Ingress. In a multi-cluster environment, Gateway API can provide unified traffic management across multiple Kubernetes clusters. This is challenging with traditional Ingress because each cluster manages its own load balancers independently. Each cluster has its own gateway resource that can be configured with the same gateway class. This allows consistent traffic management policies across clusters. Each cluster hosts different applications. In this example, Cluster 1 hosts App A and Cluster 2 hosts App B, but both can be accessed through the same external IP if configured properly. External traffic flows through a central load balancer that distributes requests to gateways in different clusters. This creates a unified entry point for applications distributed across multiple clusters. This architecture allows for global load balancing and traffic management across multiple clusters, which is essential for high availability, disaster recovery, and global distribution of applications. This multi-cluster gateway setup provides high availability, global load balancing, and unified traffic management across distributed Kubernetes clusters, which is difficult to achieve with traditional Ingress controllers. Let's examine practical use cases for Gateway API, including microservices architectures, multi-tenant applications, and complex routing scenarios in production environments. Let's examine a microservices architecture use case. In this scenario, Gateway API can route different service requests to the appropriate microservices, providing a unified API gateway functionality. Based on request paths, headers, or other criteria, the API gateway routes traffic to the appropriate microservice. For example, requests to auth * go to the authentication service, while user * requests go to the user service. Another important use case is multi-tenant applications. Gateway API allows you to route traffic to different tenant-specific services based on host names, headers, or other criteria. This demonstrates how Gateway API enables sophisticated traffic management patterns that are essential for production environments with multiple tenants, microservices, and complex routing requirements. Now let's look at actual Gateway API code examples. These YAML manifests show how to define gateway class, gateway, and HTTP route resources in practice. First, let's look at a gateway class example. This is a cluster-scoped resource that defines a class of gateway that may be requested by users. A controller implements gateway classes to provide specific functionality such as load balancers or service mesh gateways. Next, here's a gateway example. This is a namespaced resource that represents a load balancer operating at the network edge. It receives traffic from outside the cluster and forwards it to Kubernetes services. Finally, here's an HTTP route example. This routing resource specifies how HTTP traffic should be forwarded from a gateway to Kubernetes services. It contains matching rules, header manipulations, and traffic splitting capabilities. In summary, Kubernetes Gateway API provides a more powerful, extensible, and flexible approach to traffic management compared to Ingress. It addresses complex routing requirements, supports multi-protocol traffic, enables advanced security features, and works well in multi-cluster environments. Adopting Gateway API is a key step for organizations needing sophisticated traffic management in their Kubernetes deployments. Thank you for learning about Kubernetes Gateway API. Understanding these concepts will help you implement sophisticated traffic management solutions in your Kubernetes clusters. Remember to consider Gateway API when you need more advanced routing capabilities than traditional Ingress provides.